Hello everyone, in this video we will learn everything you need to know about this nice problem, that is x to the power x is equal to x. We will find all the values of x that satisfy this equation, then after that we will verify our answers, and lastly we will go through how the graph of this function looks like. I have already solved this problem on my main channel, but this time around I'm gonna use a different approach. But before we begin, you know the deal already. Pause the video and try first. And if you are new here, consider subscribed and also don't forget to like this video. Now let's get started. Based on the analysis I did for my main channel on this problem, a lot of people solved it using the power rule that states that if a to the power b is equal to a to the power c, then b is equal to c. Now, if we apply the same idea here, then it means we have x to the power x is equal to x, and this x is to the power 1. Okay? Now, since the bases are the same, then we can say that x equals 1 is a solution to this problem, right? But the question is x equals 1 the only solution to this problem? No. X equals 1 is never the only solution to this problem, right? So in this video, we will find the other solution to this problem. But before we make progress, one important thing you should understand is that x is never equal to 0. Now, why am I saying this? If x is equal to 0, then it means on the left-hand side of this equation, we have 0 to the power 0, which is indeterminate, right? So let's start. We have x to the power x is equal to x. Now let's go ahead and then take absolute on the both side of the equation, right? And then introduce natural log on the both side, okay? So I'm gonna move this x to the front. So we have x ln of the absolute of x is equal to the ln of the absolute of x, right? Now let's go ahead and then move the whole of this to the left, okay? So we have x ln of the absolute of x minus the ln of the absolute of x, and this is equal to 0. Now you can see we have ln of the absolute of x here, and then the exact same thing is here. So we can factor it out. So we have ln of the absolute of x into x minus 1, and this is equal to 0. Okay? Now from here we can say that x minus 1 is equal to 0, or ln of the absolute of x is equal to 0. Now making x the subject from this equation, we have x is equal to 1. Or from here, if we introduce e on the both sides, we have e to the power ln of the absolute of x is equal to e to the power 0. Now you can see that this ln and then this e will undo each other, so we have the absolute of x is equal to e to the power 0 is nothing but 1. Okay? So at this point, we have been able to prove one solution that we did earlier, that is s equals 1. Now let's focus on this equation, that is absolute of x is equal to 1. Okay? Now, the piecewise definition of absolute of x is equal to x when x is greater than or equal to 0, and then negative x when x is less than 0. Okay? Now from this piecewise idea, it means that if I have the absolute of a equals b, then it means that it is either a is equal to b or a is equal to negative b. Okay? So this implies that the absolute of x equals 1 also implies that x is equal to 1 or x is equal to negative 1. So we can say that the other solution to this problem is x equals negative 1. Now the question is, does this value of x satisfies the equation? Now let's go ahead and test and see. We have x to the power x is equal to x, right? So if x is equal to negative 1, then it means we have negative 1 to the power negative 1, and this is equal to negative 1, right? Now, if I have a to the power negative 1, this is the same as 1 over a, okay? So I can write this as 1 over negative 1 to the power 1, okay, which is still 1 over negative 1. Right. Now, if I have 1 over negative a, then this is the same as negative 1 over a. Okay, this is the same as negative 1 over 1, and any number over 1 is the number itself, so we have this to be negative 1. So now that we know that negative 1 satisfies the equation, let's go ahead and then check how the graph of this function looks like. Okay, now we have x to the power x is equal to x. So let's go ahead and then let y1 equals x to the power x, and then y2 equals x. Okay, now if you look at this graph, you can see we have a straight line passing through the origin. Okay, this line is nothing but y2 equals x. Alright, it is passing through the origin. Okay, and from this graph, this line is y1 equals x to the power x. Okay, it starts from 1 and then goes all the way to infinity. Okay, now if we put everything together, we have this. Okay, and this line is y1 equals x to the power x. Okay, and this is y2 equals x. Now, if you look on this graph very carefully, you can see that these two lines intersect at this point, that is 1 and 1. Alright, so it means that y is 1 and then x is also 1. Okay, now if I click on this line once, you can see we also have another point here, that is negative 1 and then negative 1. The graph didn't show it well, but it is telling us that it has 2 points of intersections. Okay, that is x equals 1 and then y equals 1, and the other point is negative 1, negative 1. Okay, so guys, we can conclude that the value of x that satisfies this equation is x equals plus or minus 1. Okay, so I hope you found this video useful. Please consider subscribed so that you get more videos like this, and also like this video. Have a nice day and then see you again on the next video.